we did differentiation rules, the different 5 types of differentiation. You can just go over that video. Power rule, then we went over chain rule, we did product rule, quotient rule, and the exponential rule. We're looking at all the general forms, and then we are basically solving the different types of rules. Okay, so now we are doing the balance of the rules. We did 5 rules. Now the balance of the rules is, let's see, rule number 6, continuing from the last lecture. Rule number 6, we are looking at the log rule, logarithmic rule. So you just need to look at the form of the log function and see what you need to apply, right? So if you have y equals log f of x base a, it's better to convert the log into a len. So we say y equals log, convert the log into a len. So you're going to say y equals log f of x base a. Okay, I can write this down and then I can explain. Okay, let's write this as a len. So we're going to say len f of x over len a. Now remember, len a is a constant. So when you're finding the derivative of len f of x, take the 1 over len a out, right? And when you're finding the derivative of a len function, it's just f prime x over f of x. Basically the len falls out. So let's take an example. All right, taking an example, if you are looking at y equals, always simplify first and then differentiate. So if I'm looking at len x squared plus 2x minus 3, what's the derivative? What is dy dx? That's another symbol that we use for derivatives. What is the derivative of y with respect to x? So we will take the function in the denominator. Anyone wants to give it a try? What's going to go on top? Yes, Mesa?
Where's the question? Wait, Ghazali. What's the question?
The question is len, open bracket, x squared
Mister,
plus
I
2x
got
minus
1 over len multiplied by 2 2x plus 2 over the base function,
yeah,
or the original
remember,
function. 2x plus
remember,
2, right?
yeah, there's no 1 over len because this is already len. So this was for a general log function. I
Ah,
converted the
okay.
log function into len f of x.
Into a len
You see,
function.
yeah,
Okay, by using the log rule, right?
yeah. This is
Yeah, okay.
basically, this is
Okay.
basically the derivative of len f of x. Okay, and that 1 over len a is just a constant. Okay, so what you're going to get on top is the derivative of the inside function, which is 2x.
2x plus 2.
Right, excellent. That's your answer. Right, you can simplify further, but there's no need. Now, why the len rule is powerful? Because you can apply different rules to, you don't need to apply chain rule, power rule, quotient rule, and all that. See, if I have y equals len 5x plus 3 to the power 20, there is no need to go and apply the chain rule here and len rule. You just going to apply the you can just apply the len rule here. Remember, if you have len of a to the power p, the rule becomes the p goes to the front, it becomes p len a. Okay, so remember that form. So rule number 1 is always to simplify, then apply the rule. So y prime will be, not y prime, y equals, simplify first, take the 20 to the front, 20 len 5x plus 3. Now it's easy. Say dy dx is equal to, you do nothing to the 20, so you just keep the 20 there, right? And then we differentiate. We put the 5x plus 3 at the bottom. and we just differentiate 5x plus 3. We just get, what's the slope of 5x plus 3? 5.
5 over 2x, I think. Or 5 over 2.
What do you mean 5 over 2? It's 5 over 5x plus 3. Ln falls out. You see, this goes to the denominator and find the derivative here. So it's 5 over 5x plus 3. Are we good?
Yeah.
Right, excellent. I should say the derivative, differentiate. So let's put the derivative. Right, and this is, that part goes to the denominator. Let me give you something more difficult with the rule like this. I will say y equals log x squared minus 3x base x. Now what we're going to do, we're going to convert this into, we are going to convert this into ln form because it has a log there. So we're going to say ln x squared minus 3x divided by ln x. Now remember, we have a problem. This is not a constant. We have a function over function. So this is f over g. So anyone remembers what rule we're going to use there? We're going to use, no, we're going to use the combination, yeah, combination of quotient and ln rule. So you're going to find f prime g. So dy dx is equal to, listen, I'm just differentiating. I'm not really simplifying here, okay? So we're just going to differentiate this. Obviously, I didn't put condition like x must be positive and that must be, right? That's finding domains of function. We're just trying to differentiate here. So if we find the derivative of the top function, we will get x squared minus 3x in the denominator, and then differentiate x squared minus 3x. I will get 2x minus 3. Then leave the denominator, ln x, subtract, okay, subtract what? Differentiate the denominator, you take the x to the bottom, differentiate x, you put it on the numerator, and leave the top function, which is ln x squared minus 3x, and this entire thing is over the denominator squared. Right? That's my answer. Now, how do you go about simplifying this function? Obviously, you need to take out an x here, take an LCD, lowest common denominator, from this term, and then simplify, okay? So you can try that out.
I have a question.
Yes, what is the question?
Can you solve y equals 3 to the power of x cubed minus x?
Okay, that is an exponential rule problem.
Yeah.
I will take that question at the end because I've explained in the previous rule that solving something like this, you just bring the question down and you differentiate the top only. That's a very simple question.
No, but in the book here they use chain rule.
No need to use chain rule. That's just
So that's why I'm confused, because he differentiated it using chain rule.
No need. Okay, look here. We are looking at the log rule at the moment. I hope you guys understood this. So I did 3 examples on the log rule. Let's move on to the next rule. Right, so this was rule number 6, logarithmic rule. Next rule we are looking at is called trigonometric differentiation, the big one, right? Trigonometric differentiation. Now we need to know the derivatives of every single trigonometric ratio. There are 6 trigonometric ratio. There are 3 normal ones, sine, cos, tan, and the reciprocal of that is cosec, sec, and cot. So we need to know the derivatives of each. So far what we know is that the derivative ddx of sine x is equal to cos x. What does ddx means? You can also write this out as, okay, it's just another form of writing derivatives. We can say if y is equal to sine x, then the derivative, we proved using first principles that the derivative of sine x was cos x. Remember, where does this here come from? I finished show you the proof, right? This came from first principles. You can go over lecture number 5. I proved that towards the end. Now, the derivative of sine x is cos x. And remember, the derivative of cos x is
It's minus
negative
sine
sine.
x.
Yes. Now, whenever you're differentiating anything that starts with a c, especially in trigonometric function, you'll always have a negative. Just remember that shorthand rule. Now, the rest of the derivatives we don't know, so we're going to apply quotient rule on the rest of the derivatives and find a rule for all of them, and I will summarize everything at the end. All right, so next one I'm trying to find is the derivative of tan x.
Secant squared x.
Look, we're not going to learn the rules. It's very simple at the end. At the first stage, we need to go and find the derivatives of each function. So let's write tan as sine x over cos x. No use learning rules. I can't even remember any rules. After I teach you this, then I will be able to remember all the rules. Okay, sine x over cos x. Now, we can see that sine and cos are trig functions, okay? We have f on top and we have g at the bottom. All right, so if I find y prime, the derivative, what's the derivative of sine x? We are using the quotient rule, so f prime g minus g prime over f over g squared. Derivative of sine x is cos x, and if I leave the denominator, it will become cos x. Subtract, derivative of cos x is negative sine x, okay? And then leave the numerator, it is sine x divided by cos squared x. Now what do you have on top? You got cos squared plus sine squared on top. You got cos squared x plus sine squared x on top, and you got cos squared x at the bottom. Right? We know that cos squared plus sine squared is equal to 1 on top because that's the trig identity. So what we are left with is 1 over cos squared x, the derivative, and 1 over cos squared x is sec squared x. Are we good, guys? This one?
Yeah, makes sense.
Now, we found the derivative of tan x. Let's find the derivative of the other 3 ratios, okay?
Ghazali,
Yes,
cosine squared x plus sine squared x is 1.
yes.
Okay.
And cosine squared x minus sine squared x is cos 2x. That's a double angle. All right?
Okay.
Yeah, all right. So now we're looking at the derivatives of other trigonometric forms, which is y is equal to 1 over y is equal to cosec x. So we're going to say y is equal to cosec x is 1 over sine x. The derivative of 1 is 0. Leave the bottom. No need, right? So 0 minus. Differentiate the bottom. Cos x. Leave the top is just 1. Divided by sine x squared.
Mr. Ghazali,
Yes.
during the exam, will they ask us to prove this, or
No. I'm not really proving it. It's more like application of quotient rule. I'm just applying the quotient rule everywhere.
Okay.
So I'm going to summarize everything in a table for you after I'm done with these derivatives. You must know where to get it from. Right. So it's good to know where it comes from, right? So you don't just learn it like off like a parrot. You have to know. Right. So what we have over here is derivative of cosec x. So we can say now that this is equal to negative cosec over sine. Okay, negative cos CSC. All right, let's use CSC, cosec x. I'm splitting this up, all right? So leave the 0 out. There are 2 terms. So cos over, just leave the cos x as it is. Cos x 1 second, split the denominator into two parts, right? So we have 1 over negative 1 over sine x times cos x over sine x. If you split the denominator into two parts, then you can see the reciprocal ratio, right? So we know negative 1 over sine x is basically cosec x, negative CSC and cos x over sine x is cot x. So what's the derivative of cosec? The derivative is negative cosec cot x, okay? That's the derivative of cosec x. Now we only have two left, which is 1 over sec and cot. Y is equal to sec x. What's the derivative of sec x? Y is equal to 1 over cos x. So y prime will be, derivative of 1 is 0, leave the bottom, which is cos x. I'm not going to multiply the bottom, subtract, differentiate the bottom, which is negative sine x, and leave the top, which is 1, right, divided by cos squared x, right, because you're squaring the denominator. So now your y prime is 1 over cos x, split the denominator into two parts, and then take sine x over cos x, because negative and negative is just plus. So the only thing that you have on the numerator is sine x over cos x. Right, so what we have is 1 over cos x is sec x, and sine over cos is tan x. So what's the derivative of sec? Derivative of sec is sec x times tan x. And now we have the last one left, which is y is equal to cot x. So what's the derivative of cot? We can't find the derivative, simplify first. We're going to say cos over sine. So y prime is derivative of cos is negative sine x dot sine x, subtract derivative of the denominator is cos x times cos x, okay, and over the denominator squared, which is sine squared x, which is, now you can take out a negative and you'll have to sine squared x plus cos squared x over sine squared x, sine squared x plus cos squared x over sine squared x. So you got negative 1 over sine squared x, and negative 1 over sine squared x is negative cosec squared. Okay, so the derivative of cot x, is negative cosec squared x. That's what it is, right? Now you can see that c, it starts with a c, so it's negative. Now how can I summarize everything? How can I summarize all these four into a table? Very simple. What you need to remember is the first two parts. You have to remember that the derivative of sine is cos and the derivative of cos is sine. This is from first principles. Right, now we can summarize all these four into a table. So what is the table? Very simple table. So we start with sec, tan, cosec, negative cosec, and cot. Now how do we apply this table? To apply the table is very simple, right? So we summarize this entire thing. This is a summary basically of the four derivatives that we did. Now how do we apply this table here? You need this table for both derivatives, trigonometric derivatives, and integrals. To apply this table, if we differentiate sec, watch here, if you differentiate sec, you get the other two. So if I ask you what is the derivative of sec x, you're going to say the derivative of sec x is block of 1 sec, you're left with sec tan. Sec x, tan x. If I ask you what is the derivative of tan x, you're going to get sec squared x. Derivative of tan is sec times sec. Okay? Now if I ask you what's the derivative of cosec x, you're going to tell me, okay, derivative of cosec x is negative cosec cot. You're left with the other two. If you differentiate one, you're left with the other two. And what about the last one? What's the derivative of x? We just did this one now.
Negative CSC squared.
Excellent. Okay, so I hope you understand how this table works now. Are we good, guys? This one? Misa?
Yeah, that makes it a lot easier.
Yes, I'm
actually.
understanding.
Yep.
Of course.
Yes.
So if
yes.
you remember this rule, you already know all 6 rules then. Now,
Yeah.
these are just rules. Now, how do I go and apply this into differentiation? So I'm going to do one example, 3 examples here, 7.2. So you will get
Mister,
questions like this, yes.
there's something in chain rule. I don't think if you explained it. It's called the power chain rule, not the normal chain rule. The
Yeah, I'm
power,
coming to that. I'm going to use that in implicit. I'm coming there.
because that one's difficult. The power chain rule.
No, we're coming there. We're going to do it now. We're going to do it in the session. Right. So you are going to get derivatives like this. So you're going to say y is equal to sine 5x. Now, you can see the entire function is sine x. We have to differentiate. So what you do is you start differentiating from the left. You're going to differentiate sine x, the entire thing, and then you go on the inside and differentiate that function as well. So you're going to say y prime is equal to, what's the derivative of sine x? Cos 5x times, because 5x itself is a function, times the derivative of 5x, which is 5. Are we good, guys? That's the answer.
Wait,
So
Mister,
there's
don't
two-
we use the
Wait,
don't we use the
how-
chain rule
how?
for this? Because
No, no,
it's
no.
it's
Yeah.
one function multiplied by another function, so it's
No,
sine
no, no,
x
it's not.
times
No,
5.
no, 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 no.
No?
It's just one
It's
function.
within the other function.
Look, sine 5x is just one
Yeah.
function, because I should have put a bracket here. Sine 5x is
Oh,
sine
that
of the
bit, okay.
angle. Sine of the
Yeah.
Mister,
angle.
but the
Sine of the
derivative of
angle
sine
5x,
5x.
Yeah.
Derivative of
5x
sine
is
5x is cos 5.
cos 5x times 5.
No, cos 5. Where did you get the 5x from?
Okay, because what's the derivative of sine of the angle? Cos of the
Cos.
angle. Cos of the angle.
Cosine. Ah, the derivative of 5x is 5.
Yes, that's where that is coming from. Are we good? That's how we apply this
So
problem.
it's basically the derivative of cosine. So and then the inner function stays the same, and then times the derivative of the inner
Yeah.
function.
Correct.
So
Yeah.
what rule is that? Is that the
This is more like composite function rule.
wow.
Is this the chain? It looks like the
Mr.
chain.
Ghazali,
Yeah.
Mr.
Welcome.
Ghazali,
Yes.
I have a question.
Yeah.
Wait, so you changed, so sine 5x became cosine 5x.
Why? The derivative of sine of the angle, don't say sine 5x, just say the derivative of sine of the angle is cosine of the angle, but the angle itself is a function. So you need to differentiate the angle as well. Yes.
Wait, so where did you get the 5 from?
I got the 5 from by differentiating 5x. The 5x itself is a
It's
function.
5. Oh, so you differentiate both of the
Yes.
both sine 5x and 5x.
Yes, correct.
Okay, I see. Thank you.
So 7.2. Right. So
Mister,
first,
sorry, is this how we write it, or will we write it like 5 cos 5x?
obviously
Bring the
you
5
need to
to the
write,
first side.
yeah, you have to bring the 5 to the front. I'm just
Okay,
showing you
okay.
the derivatives at the moment. When you're simplifying, obviously you need to bring that to the front. Where need be, there's a complex simplification, I will try to do that. Next
Yeah.
I'm
question.
remembering there was something where you
Y
had to
equals-
take like you had to take the derivative of something else, and then you had to take the derivative of something else. Oh, that was for L'Hopital's rule. So
Yeah,
because
I'm
the problem is when you take off sine derivative,
Uh-huh.
then it's cosine, but cosine is sine and then cosine is sine.
We're gonna get there. We're gonna get there. That will be the application of differentiation. Let's master differentiation first. That's why I'm going slow with the differentiation. Let's look at another problem. Y equals ln sine x. Now this is a nice problem because we just learned the log rule. So what is the derivative of ln sine x? Very simple. Y prime is the sine x goes to the denominator because you're differentiating ln as a whole, okay? So sine x goes to the denominator, okay? And you know that ln falls out when you differentiate. And what's the derivative of the sine x that goes to the
Cos
numerator?
X. Cos X.
Cos x, excellent. Now, what is cos x over sine x? Cot.
Tan?
It's cotangent.
Yes. So what's the derivative of ln sine x? Cotan x. Good. Now, guys, there's infinite problems in these examples, right? So I'm going to go over more examples now. So you say y is equal to, let me give you a complicated one. Let's try to differentiate cot cubed. Now watch for this one. Cot cubed 3x. Okay, let's not make it confusing because you got the 3 there and a 3 there. So cot cubed 5x. All we know is that we know how to differentiate cot 5x, but what about the cube? Because it's a
Mister,
cube there, we're gonna write it to the power 3. Yes.
isn't
So
it if
it's
you wrote cot cubed x, the derivative of cot cubed x is cot x to the power of 3, right?
Yes. So cot 5x.
isn't there a similar thing you use a u substitution
No
where
need
you
to
take
use
the
your
whole
substitute.
like
No.
no
need.
in later in like integrals
Yeah,
Oh
but
yeah,
this,
when you take the
yeah.
whole function as like u and then
we're not doing
Yeah.
that.
substitute back later.
Guys, you guys are
No,
way ahead. We are
Antiderivative, mister.
we are doing differentiation. Let's differentiate this function. So we see that this derivative, to find the derivative of this function, we have simplified it into a neater form, and we wrote it as f of x to the power 3, f of x to the power n. So we have to use the chain rule. So it's chain and trig together. So when we say y prime, you say 3 times 1, that's 3 cot 5x all squared. I took away 1 from the power. Now all I got to do now is to multiply, to differentiate the inside function, which is cot 5x. So to differentiate cot 5x, it is negative, what was the derivative of cot 5?
Squared.
CSC squared 5x. CSC squared 5x. Let's write it down. Negative CSC. Let me just write cosec, man. Negative cosec 5x, right? Times the derivative of 5 is 5. Okay, because remember cot 5x is a function itself. Are we good? Now we have to simplify this and try to put it in neater form. So 3 times negative 5 is negative 15, right? Cot 5x all squared. What is cosec? Cot is cos over sine, and cosec is, okay, so that's not going to help us. So we're going to write it as cot squared 5x times cosec squared 5x, right? No, cosec, sorry, this was cosec squared, all right? So let's just write CSC. CSC squared. CSC squared. Cosec squared. So CSC squared 5x. And that's my answer, guys. Okay? I wrote it in a neater form.
Yes, I don't understand. Explain, please.
Okay.
Why
So we
did
did
you
the
square it? Isn't it cubed? You're supposed to cube it.
Okay, tayyib, but then we're minusing 1 from the power because we are applying the chain rule.
Yes.
So we minus 1 from the power because it's chain rule, and then we have to find the derivative of the inside. The derivative of the inside function is all of this. That
So the 3 cot x, you took the 3 out as a common factor.
no common factor. 3 times 1. We are doing differentiation. 3 times 1 is 3. Cot 5x to the power 2. If you go to your rules and remember the chain rule, what was the chain rule? The rule.
Oh, yes. F.
There.
Chain rule is f of x.
There's your chain rule here. Can you see my screen? C times n is Cn, f of x to the power n minus 1, find the derivative of the inside. That's what it is.
So you find the derivative of the inside and then you multiply by the derivative of the outside.
The derivative of 5x.
So you apply chain rule here.
Yeah. Chain rule and trig rule. Are we good, guys?
Yes.
Right. Excellent. All right, so these are some of the problems that we can get. Also, we can also get an example like this. I just thought of one example, which is y is equal to ln sine x to the power cos x. How are you going to simplify this? Very simple. This is to the power, so the power goes to the front. Are we good? So cos x dot ln sine x. So what we have? We have f and we have g function. So product rule mixed with trig rule mixed with ln rule. Okay? Product, ln, and trig rule. There's a mixture of 3 rules there. So overall, it's a product rule. So let's look at f and g. These are my function. This is f, and that's my g function. Okay? So what is y prime? Derivative of cos x is negative sine x. Leave the ln sine x as it is. Plus, what's the derivative of ln sine x? The sine x goes to the denominator.
And it's cos x on top.
Excellent. Cos x on top, and then leave the cos x. We will try to simplify as far as possible. Well, I can't really simplify, so I'm just going to leave it like this. Cos squared x. You can combine this cos with that cos, and
Mr.
yes.
How is the derivative of ln sine x cos x over sine x?
Okay, so if you remember the log rule,
Yes, I remember it.
okay, so that's what we started off with. You see, to differentiate ln f of x goes to the denominator, and you differentiate f of x, put it on the numerator. So,
Okay,
if
so
you're
you
going to-
obtain the derivative of the numerator, which is cos x, and then you move the
Correct.
denominator to sine x. Okay.
yeah, and the ln falls out. Okay, so this is my answer, guys. Obviously, the simplification part is simple because cos x, we can combine that and write the entire thing over sine x, right? So it's possible to do that. You know what? Actually, the simplification will be. I'm just thinking if the simplification will actually be beneficial for us. No, not really. When we are doing what you call maximization, then I will do the simplification there. It will make much more sense that why we are solving for x and why we are simplifying. For now, just write the first part of the derivative like this, right? So what we have done was the
I'm getting
rule.
flashbacks when you said maximization. I got
Excellent.
flashbacks.
Okay, so we got the log rule. We did the trig rule, right? So I did 4 examples on trig rule. I'm going to move on to the next rule, right? Which is number 8, right?
Mister, before you continue, I just wanted to confirm, the derivative of y equals ln sine x is y like y prime is equal to cos x over sine x, right?
That's correct.
Okay, so all we're doing is we're differentiating
Moving
the
inner
we're putting
function
the
of the
differentiated in the numerator and then putting the original in the denominator, right?
yeah,
And
the
removing the
function.
ln completely. Okay,
Yeah,
okay,
correct. That's
I
correct.
see.
And overall, we use the product rule. So you can see the
Mr.
f
Zani,
prime g plus g prime f. Yes.
how is ln sine x cosine x over sine x?
Yeah, because if you remember the rule, okay, let me just write on the refresh the rule for you. If you have y equals ln f of x, when you're finding the derivative of ln f of x, it becomes f prime over f. That's it. So you take the function to the denominator and you differentiate the function on the numerator and put
Oh,
it on
because
the
the
numerator.
derivative of sine x is cosine x, and then you put it. Okay,
That's
okay, I
correct.
see, I see.
Excellent.
Thank you.
Right, you're welcome. Right, now let's look at let's look at part 8 of the differentiation techniques. Part 8 I would do is implicit differentiation. All Right, so we will do implicit differentiation. Now, what is implicit differentiation? We have to treat the function, we have to treat y as a function in x. So implicit differentiation says, okay, y is equal to f of x. That's it. So if I'm saying y prime, then I have to say f prime x. That's what implicit differentiation is. And then what happens if I raise this function to a power? Or if I say, okay, y is equal to f of x to the power n. So if I try to find y prime, implicit differentiation is basically just uh, power rule. Is basically just the derivative. You just need to remember notations. So if I say y prime here, then this will become n f of x to the power n minus 1 times f prime x, right? But now in problem solving, you got to replace these things, okay? You got to replace these things with n. What is f of x? Just y to the power n minus 1. And what's f prime x? Y prime. Are we good? If you remember this, I'm just trying to substitute this inside here. Are we good, guys? What is f of x? Y to the power n minus 1 times y prime. So let's look at a simple implicit differentiation problem, and then we will solve problems after that. So 8.1, right? So an example of implicit differentiation. So I will find, remember in implicit differentiation, you can't really solve for y prime. You're going to have answers in mixed up with x and y. For example, we have x squared, 1 second, we have y is equal to sine x y. I want to find the derivative of this function now. Now we got a problem because we got y on this side and y on this side. So it's kind of like impossible to solve for y, right? So we can't solve for y, we use implicit. So in implicit differentiation is basically an equation involving y on both sides. Or I can make this y squared here. Let's find the implicit differentiation of this. So this is implicit. Okay? Now, on the left hand side, what I see is what? What I see on the left hand side is a chain rule. And what I see on the right hand side, remember you have to think of y as a function in x. So basically this is f of x all squared. And this is sine x times f of x. Okay, so we got trig mixed with product rule here on the right hand side, and on the left hand side we got a chain rule. So let's find the derivative. So I'm going to write a heading here. I'm going to say y prime is, or dy dx is. What is dy dx? Let's see. What's the derivative of y squared? It is 2y times y prime, because you have to differentiate the inside. It's chain rule. You understood that? This here is a function raised to the power. So that's why it is chain rule. You have to differentiate the inside. You have to write y prime equals the derivative of sine xy is cos xy times the derivative of the inside of here, which is product rule. So let's do the product rule here. The derivative of x is 1, leave the y, plus the derivative of y is y prime, and leave the x. Now all I need to do is solve for y prime, okay? Is everyone understanding? Do you have any questions at this stage? Because now I finished do the derivative. If you have questions, you need to ask me now, because
Mister, I don't understand where you got 2y times y prime.
right, excellent. Nice question. Remember, I need to treat y, basically, what you are doing is you need to write y squared as a function in x. So watch here. Let me do one more
So
step
basically you derived, so the derivative of y squared is 2y, and then times y1 becomes y1 because it's y to the power of 2 minus 1, right?
No, it's not y1. It is y prime. It's a derivative. basically what you are doing with implicit is you're saying d dx. I'm going to expand this whole thing because you're confused. I'm going to write f of x to the power 2, right? And on this side, I'm going to write d dx because you're doing implicit, so you're differentiating both sides. Sine x times f of x. I want to use round and square brackets, so I don't want to confuse you, right? So I expanded y in terms of f of x. I'm finding the derivative of this. What is the derivative of f of x all squared? It is 2 f of x. That's why I don't like to write f of x, because it's faster like this. So let's see. What's the derivative of f of x all squared? It is 2 f of x times the derivative of the inside, which is f prime. So what did I write here? 2y times y prime. Are we good, guys?
So the
Then
derivative of y squared is y prime.
the derivative of y squared is 2y times y prime. I just proved it here. I replace y with f of x. I replace y with f of x all squared.
Is that a rule
I'm
here?
just
2f of x times f prime.
this is the rule for chain rule. This is chain rule. There, I just showed you the chain rule. If I have f of x to the power n, it becomes n f of x to the power n minus 1 times the derivative of the inside function. Okay?
Okay.
So this one is d dx of sine x. So this is now cos x times f of x. Sine of the angle is derivative of sine of the angle is cos of the angle. But now on the inside, we have to do a derivative which is involves product rule, because it's x times f of x. Derivative of x is 1. Leave the f of x, plus derivative of f of x is f prime x, and leave the x. So what did I write here? I skipped these two steps. I went straight to the answer. So what's the derivative of y squared? 2y times y prime. Right, so now you can see f of x is y, f prime is y prime. You can see now f of x is y, f of x is y, f prime is y prime. Are we good? So instead of writing y as f of x, I just differentiate using chain and treat y as a function in x. So now my answer is 2y times y prime cos xy. Now I need to go and solve for y prime. So on this side is just 2y y prime equals, expand this because there are two terms there, cos xy, y cos xy plus y prime x cos xy. Right, now you can see you need to group all the y prime x and the y prime x on the left hand side. So I will factor it out. I'll say y prime into 2y. Remember, if you bring this term over, it's going to become negative, and you can take out a y prime from there. You'll be left with x cos xy, right, is equal to, we left this term on this side because it involves no derivatives there, which is y cos xy. Now I just need to take this and divide it by this. Basically, you're dividing by 2y minus x cos xy because you are solving for y prime. So y prime is equal to, what is y prime? It is dy dx. It is equal to y cos xy divided by 2y minus x cos xy, and you can't simplify this at all, right? The reason why it's called implicit, because your answer contains x and y. Answer contains x and y. If you look at all the previous derivatives that we did prior to this, it was all explicit differentiation. This is now implicit because answer contains x and y. This implies it is implicit. Okay.
So here you isolated y prime, right?
Yeah, I factored y prime from both sides. It's like I skipped a step. I brought the y prime x cos xy to the other side, and I only took out y prime because the idea over here is to solve for the derivative. Remember, the question is to find the derivative. So I found y prime, and on the other side, I don't have any y primes. You have to always solve for the derivative.
Mister, I sent you a question in the chat for the implicit. Can you solve it?
Okay, I will do that question. I hope it's not finding equation of tangent lines and stuff.
No, 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 no. It's
Okay,
see it, see it.
I will have a look at it. All right, so we have a question here. X plus sine y equals y plus 3. This is finding the second derivative. It's very simple question. Let me just write it out. X plus sine y.
Yes, it's
Uh,
x plus sine y.
one second. This is a nice question. We can do it under our examples because it's quite simple. With all the knowledge that you have, is you can solve it. You got x plus sine y is equal
Equals
to
y plus 3.
y plus 3. And we want to
Uh,
find the second derivative, d squared
d
x
d squared y over dx squared.
d squared y. So basically this here means, guys, that we are finding the double derivative. Not the first derivative, the double derivative. It's quite simple because let's look at this. We just did an example like this, but this is much more easier because there's no product rule taking on place here. So if you find that, let's find the first derivative, right? So d dx. This is the first derivative, d dx, which is y prime. Derivative of x is 1 plus, what's the derivative of sine y? Cos y times y is a function in x times y prime. Okay, guys?
Okay.
Right. I'm done with the left hand side. Let's move on to the right hand side. What's the derivative of y? Y prime. That's it. Easy. Now you can solve for y prime, obviously. We can take this 1 over to the other side, bring the y prime over. So I'm trying to group this one and this one together. All right. So I'll take out y prime as a common factor. I'm left with cos y minus 1 is equal to negative 1. Actually, bring the y prime to the, yeah, it's fine. Remember, I can multiply both sides by negative 1 now and make it positive. So y prime is equal to 1 over 1 minus cos y. I'm just switching this because I'm multiplying by negative.
Mister, can't you
Yes.
just do y prime divide y prime?
You can't because you also have a 1 here. You have to factor out the y prime always. You got a 1 here. Then you're going to be left with 1 over y prime. You got a problem. Right, so I took out a y prime, and you should get 1 over 1 minus cos y. So basically, if you brought this cos y over, you would have had 1 minus cos y. 1, right, so now this is y prime. Now we want to find the double derivative. So we're going to say y double prime, okay? So we can just go and apply the quotient rule here, okay? So the derivative of 1, watch here. This is f and this is g. So the derivative of 1 is 0. Leave the denominator, so still 0. The derivative of the denominator is, we're differentiating cos y. We're going to end up with negative sign, and negative makes a positive sine y, okay? Times y prime. What is, you still have to differentiate y, which is y prime, okay? And then leave the top, times 1. All over the denominator squared, so which is 1 minus cos y all squared, okay? So now if you are solving this, very simple. Remember what is y prime. The problem is that we're trying to find double derivative, but we also have a y prime here, okay? So what is y prime? We already saw for y prime, which is 1 over 1 minus cos y. So we'll sort that out as well. So let's rewrite this. I'm going to write it as a split here. 1 divided by, see, I'm splitting this term. So I'm going to say negative 1 over 1 minus cos y all squared times sine y times y prime. You understand this? I just separated one part from the other. Why? Because I want you to see this, that all this is still on the numerator. See the denominator part, I kind of like just separated it. Okay? Because if you have numerator over denominator, you can always write 1 over d times n. That's what I'm doing. Okay? So, this is the denominator part. I pulled it out and there's a negative 1 here. So that's out. Sine y times y prime. Now, question is, what is y prime? How can my implicit differentiation contain a y prime as well? But we know what is y prime. It is 1 over 1 minus cos y. So you need to substitute from here back in there. So what's the answer here? Negative 1 over 1 minus cos y squared times sine y times 1 over 1 minus cos y. And now you can see 1 minus cos y squared. You can group them up. And you got negative 1 times sine y, which is negative sine y over 1 minus cos y all cubed. Okay, and that's my implicit differentiation for this. Are we good, guys?
Yes.
Can we solve for y explicitly? No, we can't solve for y. Yeah,
Mister,
yeah, that's my answer.
when I was looking at this example in the book, they solved it in a way that I don't understand.
Do you understand the method that I taught you today?
Kind of. This kind of.
Yeah, please learn this method. This is the easiest technique
Because
that you're going to
because
learn.
the method there, they did minus y prime sine y over cos y minus 1 squared. He did this equal to minus sine y over cos y minus 1 squared times minus 1 over cos y minus
Okay,
1.
wait, just hold on, The method that they used there was they converted. Okay, guys, remember what we had here: 1 over 1 minus cos y. So remember what Meze is talking about is from the first derivative, you can also convert this into 1 minus cos y to the power negative 1 and then apply chain rule. Okay, you're gonna put the negative 1 in the front, 1 minus cos.
Ah.
Master,
Yeah.
isn't this like really important for the differential equation?
Differential equation will come later on, but not
Bro,
so.
this is the most important lesson, bro. This was the AP Calculus exam last year. 60 questions on the
No,
implicit.
there was only a few questions, like very few questions on implicit differentiation. Mostly
Bro,
was
the
just
whole exam was
integrals
implicit,
and
bro.
chain rules, derivatives. And
Yeah,
for the
yeah,
written
guys.
part, it was optimization questions. You know, like you said, maximization.
Yeah,
Mostly it was
yeah, these are easy.
optimization in like physics, applications,
All right,
finance, and all that.
guys. All right, we'll look at papers at the end. Let's learn the rules now. That's the reason why we are here. Right, so we got negative sine y over 1 minus cos y all cubed. If you understood the method, what implicit differentiation is about, it's just combining all the different rules. You just need to remember that y is a function in x. Y is always f of x. That's it. All right, so now let's look at another example, right? On implicit, I will look at a circle, right? And x squared plus y squared is equal to, okay, let's just say x squared plus y squared. Let me mix it up with e to the power uh, x squared, right? Now we have a e, great. Now how are we going to solve this? Let's use implicit. We want to find the first derivative only. Why the first derivative? Because the first derivative gives the slope of the tangent line, okay? So that's the reason why finding the first derivative. So now let's find, we're going to do an application based question here. We're going to say x squared plus y squared is equal to e to the power x squared at 0 and 1. So I want the slope, find the slope of the tangent line, find the slope of the tangent line at 0 and 1. What is 0 and 1? That is the x value and the y value, okay? So if I want to find the slope of the tangent line at xy, first find the slope, so which is dy dx, right? Which is, we're finding d dx on both sides, so we're differentiating here now. Let's just call it y prime. Let's find it, let's say just call it y prime. So we're finding the derivative here. Derivative of x squared is just 2x. Remember, x squared is not it's already a function, right? But y squared, you have to apply, y is a function in x, so it's function raised to the power 2. So when you say 2y times y prime, you kind of like differentiating y. Differentiate y, you get y prime. And on the right hand side, we have e to the power x squared, so it's just e to the power x squared times the derivative of the top, which is 2x times ln e, ln of the base. But now we already, let's change this to 2 to the power x squared. So now you're going to have ln 2. Let's not write 2, let's call it 3 to the power x squared, so you're going to have ln 3. Before I had e, because if I put ln e, then that thing just cancels out. Ln and e cancels out. Ln e is just 1. So we got 3 to the power x squared, right? Now, to find the derivative, to find the slope, that's very simple. You're just going to say y prime, right? You have to solve for y prime. But now, because you are solving for y prime evaluated at 0 and 1, you can just substitute at 0, 1 here. So what's the x value? 0. What's the y value? 1. So remember, x is 0, so that is 0. Y value is 1, so 2 times y prime. Because this is an application-based problem, they did not ask you to find the derivative. They asked you for the equation, find the slope of the tangent line. The slope of the tangent line at a point is just substituting the point into the derivative form. You don't have to go and solve for y prime here now. So it is equal to what's e to the power 0, 1. 2 times 0 just 0, right? So what is y prime equal to? Because everything just worked out to be 0. So what's y prime? Just 0, because you got 0 on this side. 1 times 0 is 0. So it's just basically a constant line. Okay? The derivative is 0. In other words, the line is just flat.
Mister, explain to me again where you the second part, how you derived the second part.
Which part? Y squared?
The ex squared times
Okay.
2x
So
ln 3.
if you remember the rule for e to the power, sorry, not e. This is incorrect. Should be 3. Sorry. That should be
Oh
3.
yeah, now it makes
That should be
sense.
3. Yeah, sorry. There's no e.
Now
Remember, I
it makes
changed it.
sense.
Yeah. So 3 to the power 0. 3 to the power 0 is 1. 2 times 0 is 0. And ln 3, we don't care. So this entire thing just works out to be 0. Yeah. Are we good, guys? So what is the slope? What is the slope of the tangent line at the point 0, 1? The slope is 0. So this is the slope. Not always you'll get 0 as the answer. I just chose this point 0 and 1. If I chose other points, then obviously you'll get much better answers.
Mister, I sent you another question, see.
Okay, I'll take questions at the end. Let's look at the rules for differentiation. All right, guys. Next rule that we want to look at is number 9, logarithmic differentiation. I'm not even done with the rules now. Logarithmic differentiation. Just last rule, and I'm not going to do much problems on this because this is using rules of logs. Now, we have a problem with logarithmic differentiation because remember we're doing, if I want to differentiate something like this, y equals 5x minus 1 to the power 20 times 3x minus 2 to the power 10 divided by what? Divided by x squared minus 1 to the power 12. How am I going to do this? You can't do product rule mixed with quotient rule. The problem will become too difficult. So what we do is a logarithmic differentiation. So what we do is we ln both sides, okay? So we say ln y is equal to what? Ln of this entire thing. So now you need to use your rules for expanding ln. Let's copy this. Right, so I ln both sides. Now watch what happens. If you remember from pre-calculus, remember product of lns becomes the sum and division of lns becomes the minus. So we're going to say ln y is now equal to 20 len 5x minus 1. Where did the plus 10 len 3x minus 2. Subtract 12 len x squared minus 1. Now let me explain where I got this from now. Because you might be confused where I'm getting these from. Right, so let's say, let's just write, this is len one function to the power function to the power a. Then we have another function g to the power b, and we got a third function h to the power c. If I'm going to expand this len function, I'm going to say len f of f to the power a plus len f to the g to the power b. Okay, and then you're going to minus, because that's in the denominator, you're going to say len h to the power c. So what happens now? The a comes to the front, the b comes to the front, and the c comes to the front. And then what you do after this, all you need to do is just apply logarithmic differentiation. So what is the derivative of len y? You put the derivative on top, which is y prime, and take the y to the denominator. And then the rest of them is just easy to differentiate. No need to go and use product and chain rule. Use logarithmic differentiation. So 20 5x minus 1 goes to the denominator, and derivative of 5x minus 1 is 5, plus 10 derivative of len 3x minus 2, 3x minus 2 goes to the denominator, and the derivative of 3x minus 2 is 3, minus 12 the x squared minus 1 goes to the denominator, and the derivative of x squared minus 1 is 2x, right? And now what's your answer? Y prime is equal to y. You still need to multiply all this times y. So if you multiply by y, you say y times 20 times 5 is 100 over 5x minus 1 plus 30 over 3x minus 2 minus 24x over x squared minus 1. Now what is y? Y is the original function, so we need to make it explicit now, all right? Remember, there's further simplification needs to be done. So, but remember, it's easier to differentiate it like this. So now this is y part. That's what y was originally. So I put the y back in, and all this here remains the same in the next part. Nothing changes there, right? So that's my final answer, right? And it's a much better answer than complicating this using chain product and quotient rule, right? So y times all of this. Remember, you can still take this, multiply into the 3 terms, and make it simpler if you want. All right, guys, any questions for logarithmic differentiation? Hello, any questions, guys?